Hey guys, okay, here is our recording for, again, still 4.2, okay, increase function and decreasing function. So let f be a function defined on an interval. Let's call this interval I. And let x subscript 1 and x subscript 2 be any 2 points in interval I. Okay? F increases on interval I if x subscript 1 is less than x subscript 2. That means in the result, as a result, f of x subscript 1 is less than f of x subscript 2. Okay? And f decreases on I if x subscript 1 is less than x subscript 2, but f of x subscript 1 it's greater than f of subscript 2. Okay? So what that means is x1 always go before x2. That's all that is, okay? So I'm picking 2 points, x1 and x2. x1 is always less than x2. No big deal on either one, okay? But it increases if the y value of x1 is less than the y value of x2. So what does that mean? That means I'm going from small to big, so that has to be increases. It decreases if the y value of x1 is greater than the y value of x2, and that makes sense because I'm going from high to low. Okay, so let me give you some extra information here. Functions with positive derivatives are increasing. Okay, and so now we will use derivative to say that it's increase or decrease, which is a lot easier than before. Okay, functions with negative derivatives are decreasing. Okay. All right. Corollary. Increasing and decreasing function. All right. Let f be a continuous function on closed interval a to b and differentiable on open interval a to b. Okay, if f prime is greater than 0, which is positive, at each point of open interval a to b, then f increases on a to b. Okay, if f prime is less than 0, which is negative, at each point of open interval a to b, then f decreases on a to b. Okay, so in plain English, what this is saying is that positive derivatives is an increasing function. Negative derivatives is a decreasing function. Okay, and let's put that to use for example 4. Example 4, for each of the following, use analytic methods to find A, the local extrema, it's back, B, the intervals on which the function is increasing, and C, the intervals on which the function is decreasing. Okay, so first I need to find the derivative anytime I'm asked to find the local extrema. So let's do the derivative. G prime is 2x minus 1. Set it equals to 0. X is going to come out to be a half. Okay, I have no endpoints, so this is the only thing I am going to use. But when I have 1 point, it's kind of hard for me to see if it's minimum or maximum, so make sure I use like a negative 100 or positive 100. Okay, so f of 1/2 is 1/2 square minus 1/2 minus 12. So with some basic math going, let's see if I can do the basic math. That's 1/4 minus 1/2. I'm pretty sure at some point I'm going to need to convert that to denominator 4, so that's going to be 48, and that into a 4, so that's going to be a 2. So that is going to be 1/2 minus 2/4, that's going to be negative 1/4, minus 48 over 4 is negative 49 over 4. Okay. Well, I kind of don't know if that's minimum maximum, so let's do some far out points. Negative 100 squared is positive. F of a positive 100 is still positive. So I have 2 positive points, and this is negative somewhere in the bottom, so this is definitely a minimum. Okay. So minimum, would you agree with that? Perfect. Min is what? Negative 48 over 4 at what? X equals to a half. Gorgeous. Okay. Let's do B. What did B want us to do? The interval. Find the intervals on which the function is increasing. Now, this is the new theorem that we just studied. Okay. So I'm still going to use that half. But I'm no longer using f of x. I'm going to use f prime of x here. Okay. So because look at the theorem says, if f prime, okay, if the derivative is positive, then that means f is increasing. If the derivative is negative, then f is decreasing. So that's all I need to do. Hey, is the derivative positive or negative? So here we go. F prime of negative 100. Okay, I already have f prime. F prime is right here. So all I have to do is plug it in. And I don't need to know whether it's, I don't need an actual value. I just need to know it's positive or negative. Negative 100 times 2 is negative. So this is negative. F prime of 100 is positive. So this side is negative. This side is positive. Okay. Well, I know f prime of 1/2 is 0. So this is right there. Because how do I know that? I found it right there. So increasing from, oops, I need to do inclusive symbol. Inclusive 1/2 all the way to infinity. Yay! And then part C said, tell me the decreasing part as well. Okay, so B and C are related. Decreasing from negative infinity all the way to 1/2 inclusive. And that's it. Easy peasy. Let's do B. B, same question. So the first, I'm going to need to find the extrema. So here we go. A, I need to do the derivative. I'm going to use the quotient rule. So here we go. F prime of x equals x to the third. So that's your u prime times x plus 8 plus x plus 8 prime times x to the third. So this is going to be 1/3 x to the negative 2/3 times x plus 8. The derivative of x plus 8 is really 1, so that doesn't really matter because 1 times x to the 1/3 is 1/3. Okay. All right, then from here, we would need to see if I can simplify this up a little bit. Okay. Okay, so can I make the negative 2/3 into positive? Yes, I can. Okay. This is already positive, so that stays on the top. Okay, the 3 goes on the bottom. So denominator of 3, so this is 3rd root of x squared. So that's what I really have. Plus over here, can I say that that's 3rd root of x over 1? I'm gonna find common denominator. So what I need to do is on this side, I would now have to multiply by 3 3rd root of x squared. 3 3rd root of x squared. Okay. Denominators are now the same. So now I can just put it over one common denominator. If that's the case, over here I still have x plus 8. Over here, I still have a plus 3, but 3rd root, okay, of those. Now, under the radical, I have x to the 3rd, and I have 3rd root, so that will cancel out. So now I just have an x. So from here, I would now have 4x plus 8 all over 3 times 3rd root of x squared. I need to find the critical point, so I need to set it equal to 0. So the first critical point is right away. Oops, why did I cross that out? Okay, the first critical point is right away. It's going to be the denominator can't be, right? So the denominator can't be 0. So the first critical point is 0. Then I need to take my numerator and set it equal to, you guessed it, 0. So that one will give me x equals to -2. So I have 2 critical points, okay? So I'm gonna now plug it into my calculator and find what? Minimum, maximum? Okay. So here we go. Let's do this thing. Okay. All right, tell me what to do. Why don't you give yourself a head start and then I'll catch up, okay? So put -2 on here, put 0 on here. Okay, then from here, I need to find minimum or maximum. So can we check? F of -2 is, we need to plug in -2 to the 1/3, okay, times -2 plus 8. So that's really 3rd root of -2 times 6, which is about -7.56, okay? And let's plug in 0. F of 0 is going to be 0. So one of it is negative. Okay, so currently this is 0. This is negative somewhere down here. And I still don't know which one is which. So let's do f of a -100. What if we have f of a -100? -100 to the 3rd is going to be negative, right? So that's on the outer piece. -100 plus 8, that's negative. So would you agree that's positive? Okay. So let's check 100. So f of 100 is positive 100 to the 3rd is positive, times 100 plus 8 is positive. So that's again positive, okay? So somewhere in the middle here. So it looks like it's starting from here, it goes to here, and then it ends up to here. So what's going on here? I'm gonna see, so does it curve back up anymore, or is it just continues to go like that? Okay, so that's really my question. And it seems like that's the case. So if that's the case, this right here, since there's not another curve go here, this 0 is neither minimum or maximum. So looks like my minimum is negative 7.56, or I can keep it as exact form as it was negative third root of 2, so negative 6 third root of 2, because I can pull out the negative from the under the third root. Okay, so what happened is third root of negative 1 is the same thing as negative third root of 1, which is really negative 1. Okay, so you can pull out the negative in the front. So the minimum is decimal, or negative 6 times third root of 2 at x equals negative 2. So that's my minimum. So that is just part A. Part B, find increasing and decreasing. So I don't need to use 0, so keep that in mind, because 0 from our chart over here, it wasn't a minimum or maximum. So for part B, oops, I'm going to use f prime of x, so keep that in mind. Okay, so this is x equals negative 2. So I'm going to plug in f prime of negative 2 to see what it gave me. And f prime equation was found over here, right there. Okay, so here we go. Equals 4 times negative 2 plus 8 all over oh, I don't need to plug in negative 2. My bad, because that already gave me 0. So sorry, I need to think for a second. Sorry, that was already 0. So that's why this is 0. And how do I know that? Because, oops, how do I know that? Because this came from that, okay? The 2 came from that right there. So that's already 0, so don't need to worry about that. But need to plug in f prime of left-hand side of that, which is negative 100. So on the top, 4 times the negative 100 is negative. On the bottom, third root of a negative 100 square. Well, negative 100 square is going to be positive, so that's always going to be positive. So this is going to be negative. So negative's right there, okay? And then, sorry, my lights in the classroom got turned off. And then we're going to do f prime of 100, which is on the top is going to be 4 times 100 is 100, and on the bottom, 4 times 100 is 400. I meant positive. 4 times a positive 100 is positive, and anything square is going to be positive. That's always going to be positive. So this is positive. Okay. So increasing and decreasing. So let's check it out. Increasing, okay, from inclusive negative 2 all the way to infinity. Decreasing, this is letter C. Decreasing from negative infinity all the way to negative 2 inclusive. And that is the end of this video.